Yes, sir.
Yeah, okay.
Yes, sir.
So now,
Above.
okay, done. So we are going to solve a problem on this category. That is from the fourth type, right? This one. This case. So in the previous problem, they had given the delta HF in terms of isentropic enthalpy drop in the previous problem, in this problem. But in this problem, they are going to give the delta HF value directly. In addition to that, the V1 value, that is initial velocity value, will also be there. Okay, so that is the difference. Mm, okay, so here it is. This is the problem, right? Now, so problem, yeah, convergent divergent nostril. Um, the convergent divergent nozzle is required to discharge 2 kg of steam per second. 2 kg of steam per second means that is mass flow rate. The nozzle is supplied with steam at 7 bar and 180 degrees Celsius. That is inlet pressure P1 and T1. That is 7 bar and 180 degrees Celsius. The discharge takes place at back pressure of 1 bar. Back pressure is nothing but exit pressure. Okay, expansion up to the throat is isentropic, and frictional resistance between the throat and exit is equivalent to 63 kilojoules per kilogram of steam. Okay, taking the approach velocity of approach velocity as 75 meter per second, this v1, and throat pressure 4 bar. We have to find out area at throat and exit and overall efficiency. Okay, areas at throat and exit, and we have to find out the overall efficiency. This is what we have to find. So here it is. This is the given data. A superheated steam expands through a CD nozzle. Before going to the problem, let me tell you something. I'm not having exact values of enthalpy, entropy, specific volume. Those things I in between the first session and this session, I cross-verified with my Molière chart, with the Molière chart available here, but there are some deviations. The values are different from the book values. So just look into the procedure only, and you try to get the enthalpy values, specific volume, and entropy value, and give me the answer. The values which I'm having on my presentation may vary. Okay, make a note on it. The values, definitely there is possibility for variations in the enthalpy, entropy value, velocities, areas value. Okay, so keep it in mind. So you tell me the enthalpy value, entropy value, and specific volume value using the Molière chart. Okay, so mass flow rate is given as 2 kilograms per second. Approach velocity, that is initial velocity, v1 is equal to 75 meter per second. Inlet conditions of the steam, p1 is equal to 7 bar, p1 is equal to 180 degrees Celsius. Throat condition is given, p2 is equal to 4 bar. Exit conditions is 1 bar pressure. Sorry, 1 bar pressure. Yeah, here now 1.5 it is actually 1 bar pressure. So this is 1. Mm, actually it is 1 bar pressure. Then delta HF is equal to 63 kilojoules per kilogram. So what are the data we have to find? We have to find the throat area, exit area, and overall efficiency. Okay, so this is the convergent divergent nozzle. So it is better you draw the diagram of nozzle in every problem. Okay, that will give you an additional advantage. So this is the convergent divergent nozzle. Okay, so this is the Molière chart diagram. Um, you can draw it in the while solving the problems also. That will give an idea how you solved the problem for the evaluator. Okay, so I'm having the, wait a minute, let me erase those things because it will disturb you while looking into the Molière chart. I'll erase all those things. Okay. So here it is. I'm having the Molière chart. Using Mollier chart, I'm going to find out the properties, that is enthalpy, entropy, and specific volume at inlet, throat, and exit. Okay. So P1 and T1, inlet pressure and inlet temperature. P1 is equal to 7 bar, and actually I first noted the temperature. Nearby, actually it is between 150. Here I'm having the value for 150 degrees Celsius and 200 degrees Celsius. I'm not having exactly 180 for the curve for the 180 degrees Celsius, so I approximated it. And 7 bar pressure line, there will be definitely 7 bar pressure lines will be there. So travel through this and get the intersection point. From there, travel to your left hand side and downwards. Give me the value for enthalpy and entropy. Can anyone tell me the enthalpy value and entropy value at state 1?
Sir, enthalpy is
278, sir.
2830, sir.
Sir, 2780, sir.
2780. Okay, somebody else is getting 2830.
Yes, sir.
Yeah, exactly. This is the problem which I faced. Actually, in book answers, I'm getting 2830. But while I referring the Mollier chart which I'm having, I'm getting 27660. So that is the value I'm getting. Okay. And S1, you may get 6.8.
6.78, 6.78, sir.
Correct. Okay. This is as far as entry is concerned, both these values are right. Enthalpy and entropy values are right. Okay. Now at throat, that is P2 is equal to 4 bar pressure. This yellow color line passes through the 4 bar line and it intersects the vertical line which I drawn now. So from this intersection point, you can get the enthalpy value and specific volume value. What is the enthalpy value you are getting?
2720, sir.
2720. I'm getting 2620. Okay. So that is deviation. Okay. What is the value you are getting? Commonly, there will be a range, right?
Yes,
JK says 2720. Somebody else saying, does anyone else have any value for it?
26 something, sir.
Okay, 26. So I'm getting. I'm going to keep it as 2620, right? And S1 is actually 6.7. This is not the right value. S1 is equal to S2 is equal to 6.7. Okay. So what is specific volume? Are you getting this value? 0.48.
Sir, 1 second, sir.
Specific volume at throat.
Okay, sir. 0.48, sir.
Okay, 0.48. Good. Now I'm going to the next state, that is exit state. At exit, the pressure is 1 bar, right? P3 is equal to 1 bar pressure. At 1 bar pressure, the 1 bar pressure line, it passes like this, and it cuts this vertical line over here. So you will get some enthalpy value around 2400.
So 2570, sir.
Okay. Anyone else? Any other answers? Okay, let me keep it as 2750, right? What is the enthalpy, the specific volume value?
2470, sir.
Okay, super. So let it be as it is, right?
Okay, sir.
நம்ம 2420 இருக்கு இல்லையா, அதை அப்படியே வச்சுக்கலாம். நாம 2470 தான டிவியேஷன் வருது. So 2420 இருக்கட்டும். Specific volume?
Specific volume,
1.5.
Okay, sir. 1.5, sir. Correct,
Okay,
sir.
super. That's it. So நம்ம கிட்ட மோலியர் சார்ட்ல இருந்து டேட்டாஸ்லாம் எடுத்தாச்சு, right? Now we have to find out throat area, exit area, and overall efficiency. Okay. So here, what is the change? அப்படின்னாக்கா there are two datas available. One is approach velocity and another one is delta HF. Delta HF value directly given in the problem and V1 value is also given in the problem, right? If V1 value is given in the problem, okay, so what we done in the previous I hope a couple of problems before we solved this model. If the inlet velocity is given, there is a change in the velocity formula. What is that?
H naught
Uh,
minus.
It's not.
H naught, yes, root of 44.72 into H naught minus H2 or H naught minus H3. If it is a exit case, formula will be 44.72 into root of H naught minus H3. If it is throat, V2 is equal to 44.72 into root of H naught minus H2. That's it. Okay. Now here our objective is we have to find the throat area. Correct. So if you want to find out the throat area, we must know mass flow rate, we must know specific volume and velocity. So mass flow rate is given in the problem, and specific volume we found out from the molar chart as 0.48. Okay, the only data which is not known to us is that velocity of the steam at the throat. So this is the formula. As you said earlier, V2 is equal to 44.72 into root of H naught minus H2. So H naught, we know the formula. H naught is equal to H1 plus V1 square divided by 2000. Right? Kindly adjust with me. There is a typo here. Actually, it must be 2830. But there was a typo. Here the value is 2760. Right? H1 is equal to 2760. So in that case, what is the H naught value we are getting? 2760 plus 75 square divided by 2000. What is the
62.
2762?
2762.
Okay, super. 2762 is the H naught value. So I'm getting the H naught value. Next, I can find out the velocity. That is V2 is equal to 44.72 into 2762 minus H1 is equal to 2760, yeah. H1 is equal to 2760 minus 2762. Answer correct ah varudha? Velocity value enna varudhu?
292.6.
292 varudhu. Okay, this is 292 meter per second velocity V2. So next step, I'm going to substitute the V2 value in this equation, and I'm going to get the area. What is the area we are getting actually?
Sir, எனக்கு 1.127 into 10 to the power minus 3 வருது sir.
Okay. Any other answers? Any other answer? No.
Sir,
So,
நான்
சார் அது மைனஸ்ல வராதா சார்?
என்னமா?
மைனஸ்ல தான் சார் வரும்.
அதான் நான் கேக்குறேன். அதனால தான் நான் இங்க எனக்கு டவுட்டா இருந்துச்சு. இந்த இடத்துல this is 2760 minus 2762 னு சொன்னாக்கா இந்த இடத்துல மைனஸ்ல வரணும்.
ஆமா சார், மைனஸ்ல வருது சார்
அது தப்பு.
சார் நான் H naught ஓட வேல்யூ வந்து 2830 னு எடுத்துக்கிட்டேன் சார்.
H naught சப்ஸ்டிட்யூட் பண்ணி தான ஆன்சர் வரணும். H1 is equal to 2760 வா?
இல்ல சார், நான் H naught வந்து 2830 எடுத்துக்கிட்டேன் சார்.
எப்படி அது எடுக்க கூடாது, நம்ம கால்குலேட் பண்ணி தானே போறோம்.
இல்ல சார், அதான் சார் நீங்க சொன்னீங்கல சார் டீவியேஷன் வருதுன்னு சொல்லிட்டு நீங்க வந்து 2000
அப்போ H naught
62 இல்ல 2620.
எங்க
V2 ல H naught minus H2 தானே throat area தானே.
ஆமா H ஓகே
H2 தான் சப்ஸ்டிட்யூட் பண்ணோம். 2620 தானே.
ஓகே H naught வேல்யூ என்ன வருது?
2762 சார்.
Wait. 2762. H naught is equal to, so V2 is equal to 44.72 into root of H naught. H naught is equal to 2762 minus what is it? H2 is equal to 2620. Right, correct. H2 is equal H2 here it is. H2 is equal to 2620. So answer velocity, answer V2
532.9.
532.90.
Okay, super. 532. So if that is the case, what about the velocity? Velocity எவ்வளவு வருது சொல்லுங்க. velocity 532 velocity சொல்லிட்டீங்க. ஏரியா என்ன வருது? மாஸ் ஃப்ளோ ரேட் வந்து 2 kilograms per second. Specific volume second stageல 0.48.
0.281 sir.
0.48 divided by 532. கரெக்டா? எவ்வளவு வருது?
Sir, 0.48. Okay sir.
0.48.
Sir,
Okay.
0.8 வருது சார் எனக்கு. 0.8.
Area answer.
1.8 sir, 1.8.
Okay. Area answer is 1.8 into 10 power minus 3.
Minus 3 sir.
Yes sir.
Okay. I'm getting 2. Here it is 1.8. Okay. Correct. So the answer is area is equal to 1.8 into 10 power minus 3. A2 value. Throat area முடிஞ்சிச்சு. Next, I have to find out the exit area. For exit area, same formula, A3 is equal to M into small v3 divided by capital V3. Already, நாம் என்ன செஞ்சிருக்கோம்னா mass flow rate, specific volume at exit ரெண்டுமே கண்டுபிடிச்சிருக்கோம். Mass flow specific volume at the exit பார்த்தீங்கன்னா it is 1.5. Correct? It is here it is 1.5. So V3, there is a change, right? V3 is equal to 44.72 into root of H0 minus H3. Okay. Now next actually H3. H3 we have to find out. We are not having the H3 value, but we are having H3s. H3s is 2420 and delta HF is 63. Correct? 63 தானே?
ஆமா சார்.
So H3, what is the value we are getting? H3 is equal to 2420 plus 63 na 2483. Yeah, 2483. Correct?
Correct sir.
Okay. Then V3 எவ்வளவு வருது? H0 is equal to 2760 minus 2483. What is the velocity value?
746 sir.
746 meter per second. Okay. Then area. So we are having velocity value, mass flow rate, specific volume. What may be the exit area value?
So 4 into 10 power minus 3 sir.
4 into 10 power minus 3. So this is the answer. Exit area, we calculated the value as 4 into 10 power minus 3. So now that's it. This is the answer. Last factor which you have to find out is efficiency. We know the efficiency formula, eta is equal to h1 minus h3 divided by h1 minus h3s. We are having all the values. H1 is there, h3 is there, and h3s is also there, right? H1 is equal to 2760, h3 is 2483, and h3s is 2420. What is the value we are getting? This is actually 2760. This is also 2760, and this value is equal to 2483. What is the efficiency?
$82.5 sir.
82.5. Okay, I'm getting 0.82. That's it. Okay, super. So 0.82, right? So this is the case actually. So far we discussed 4 types of problem. So in this problem, does anyone have any doubts?
No sir.
No. யாராவது ஒருத்தர் 2 பேர் மட்டும் தான் பேசுறீங்க, மொத்தம் யாருமே பேசவே மாட்டேங்கிறாங்க. தினேஷ், நம்ம பிரணவ், லலித் சாய்ராம் இருக்காங்களா? பாண்டி சாய்ராம், விஜய் பாலா இருக்கீங்களா எல்லாரும்?
இருக்கும் சார்.
கவனிக்கிறீங்களா? ஏதாவது டவுட் இருக்கா அதுல?
இல்லை சார், புரியுது சார்.
ஓகே ஓகே. ஸோ okay, that is the case actually. So we solved 4 types of problems so far. So first type of problem is inlet condition is given, exit condition is given, mass flow rate is given, and efficiency. And second problem, inlet, exit, mass flow rate, nozzle efficiency, and approach velocity or inlet velocity was given. Third problem, inlet condition, exit condition, mass flow rate, and delta HF in terms of isentropic enthalpy drop was given. And fourth problem, which we discussed in this session, in addition to inlet, exit, mass flow rate, nozzle efficiency, inlet velocity, as well as delta HF was given. Okay. The fourth problem is a combination of second and third problem. Okay. So that is the difference. So if you solve the fourth problem, this fourth problem consists of all these 3 problems, first 3 problems. Okay. So இந்த 3 ப்ராப்ளத்தையும் ஒண்ணா இணைச்சோம்னா 4வது ப்ராப்ளம். சரியா? Right? So I'm planning to solve another 3 problems. This is actually the last problem was an university problem. It was asked in 2019 November, I think so. So I'll solve another 2 to 3 problems in the next classes. One is cone angle problem, and another one is number of nozzles, and another one problem that will be based on condition of steam, that is dry saturated steam and wet steam. So on these combinations we will solve another 3 problems on Monday. Most probably on Monday and Wednesday we will complete this unit, and I will share you a list of problems which is compiled from previous university question papers, and you try to solve it on your own and submit an assignment, okay, on that. Okay. So just actually, what can I say, just an assessment, nothing more than that. Just you try it on your own. Don't copy, don't get the material shared along WhatsApp or by some other means and copy it, and don't produce it like that. So you try to solve it on your own. If you have any doubts means, you can ask me, and I hope these videos are available in your YouTube channels. You can refer those also. Okay. I hope till up to this 4 problems, I hope everybody is clear with the procedure and solving methodology, right? So one of the let me have a recap about this. One of the important thing as far as this particular unit is concerned, how we are going to handle the Molière chart. That is the very important thing. Okay. So you must know to interpret the data or get the data from the Molière chart with the data available with us. In problems, data with respect to inlet, throat, and exit conditions will be given. By using those data, you have to get other properties of the steam from the Molière diagram. Okay, that is important. So very basic fundamental thing which you must be aware of is that how to handle the Molière chart. That is one of the very important thing. And another thing is this one, the formulas. Another thing is this formulas. Okay. So we are not having many number of formulas as far as these problems are concerned. One of the very basic formula is velocity. V is equal to mass flow rate into specific volume divided by velocity. That is one of the basic formula. And this one, exit velocity V2 is equal to 44.72 into root of h1 minus h2. Then this one, this is for the actual case where K comes into the play, where K is called as the friction coefficient of the nozzle. and very rarely we will make use of these formulas. That is discharge through isentropic nozzle and maximum discharge through the isentropic nozzle and maximum velocity nozzle, maximum velocity through the isentropic nozzle. Very rarely we will make use of these three formulas while solving the problems. But as far as derivation part is concerned, these three formulas are very important. Okay, and these assumptions are very important. Somebody will ask why, how you are saying that S1 is equal to S2 is equal to S3. That is based on the assumption. That is flow is isentropic and mass flow rate remains constant. Last time while I was handling the subject to your seniors, there were a lot of questions. How you are saying that the flow is isentropic? How you are saying that mass flow rate is constant? The area is varies. If the area is varies as far as the continuity equation is concerned, m dot is equal to rho AC. Density may remains constant. Steam density may remains constant, but area increases. So in the diverging portion, if the area increases, it directly affects the mass flow rate since it is directly proportional. These sort of questions were raised in the last year. So you have to think about the topics which we are discussing in the sessions like that, how your seniors did, and you have to think about all these things. Okay, so you have to raise questions in order to clear your doubts. Okay, that is very important. Unless if you raise any questions about the topic, what it means is that you are simply hearing what I am saying, but you are not learning anything. That is the thing which you have to make a note on. Okay, then coming to this point, this slide, critical pressure ratio. Critical pressure ratio, this is one of the important formula. Most of the times it will be asked in your 2 mark questions, all these values. Okay, efficiency formula. And in addition to that, we use another formula to find out H naught. H naught is equal to H1 plus V1 square divided by 2000. That is another formula which we used. And delta H. Delta H is equal to or H3 is equal to HS plus delta HF. Okay. So these are all the formulas which we used so far and the problems seen so far. Okay. So just I went through all these things. So if you have any doubts, means you can get clarified over here. Any doubts?
No, sir.
No. Okay. How many of you are present? Getting only 74. I am one of the person, and I hope I think Stephen sir is there. So if he's not there, means only 72 are present. Remaining 8 absent. And while as far as attendance is concerned, let me share you the absentee list in the class group or some other groups, and you just look into it and tell me if you are present in the classroom with some proof. Okay, so take a screenshot or record a small screen recording using screen recording app. You just record the video and you send it to me if if there is any mismatch. Okay. Tanashekar, how are you?
Fine, sir.
How the classes are going on?
Nice only, sir.
Nice. Okay. So any feedback about the sessions? Yesterday itself I asked you. If you give me any feedback, means I will convey it to through proper channel. So do you have any feedbacks on this? Anybody? No. Okay. Are you? Can you getting what I'm trying to say clearly?
Yes, sir.
Okay. Okay, boys. So today Friday, isn't it?
Yes.
Sir,
Have
weekend.
have a happy weekend. 2 days leave will be there. So just go through all the topics. Okay. Niresan, he left the meeting. Okay. So What shall we do right now? Okay, let's have a small Q&A session. Just to check the level of understanding. Santosh, are you there?
Yes, sir.
Okay. What is convergent nozzle, Santosh?
Convergent.
Convergent nozzle என்ன?
சார் அந்த டயாமீட்டர் பெருசா வந்துட்டு அப்படியே ஷ்ரிங்க் ஆகும் சார்.
சூப்பர். டயாமீட்டர்னு சொல்லக்கூடாது. It is area. Okay, cross sectional area will start to decrease from the entry to the throat. அதை சொல்லணும். entry throatன்ற வார்த்தை பயன்படுத்தணும். சரியா?
ஓகே சார்.
டயாமீட்டர் கிடையாது, ஏரியா. ஓகே, அப்படியே 2 மார்க் क्वेश्चन வாட் இஸ் கன்வர்ஜென்ட் டைவர்ஜென்ட் கன்வர்ஜென்ட் நாசில் அப்படின்னு கேட்டாக்கா சொல்லணும் இது மாதிரி. ஏரியா will start to decrease from the entry to the throat. Okay?
ஓகே சார்.
சூப்பர். Then Linus.
Sir.
Types of nozzle.
Types of nozzle.
என்ன டைப்ஸ் ஆஃப் நாசல் ஃபர்ஸ்ட் கிளாஸ்ல போட்டோமே. இப்ப சந்தோஷ் இப்ப சொன்னானே ஒரு நாசல்.
சார் நான் விட்டு கேக்குது சார், அப்ப கேட்கவே இல்லை சார் சரியா.
ஓகே ஓகே ஓகே. தென் மனோஜா.
சார்
டைப்ஸ் ஆஃப் நாசில் சொல்லுமா.
types of nozzle sir. Convergent nozzle.
Super.
Divergent nozzle sir.
Another one. Combination of convergent divergent nozzle. CD nozzle. Convergent nozzle ஒன்னு, divergent nozzle ஒன்னு. இது ரெண்டுத்தையும் சேர்த்தாக்கா third type of nozzle is convergent divergent nozzle. Okay? Okay, super. நந்தகுமார். ஏகே நந்தகுமார். ஓகே, என் நந்தகுமார். Effects of friction. நான் சொல்லட்டுமா? ஹலோ,
சொல்லிடுங்க சார்.
எங்க போனா அவன் நந்தகுமார்?
மைக் ஒழுங்கா கேட்கல சார், மியூட் பண்ணிட்டு அன்மியூட் பண்ணுவோம், வெயிட் பண்ணுங்க சார்.
ஓகே ஓகே ஓகே. ஸோ decrease in
specific volume.
Okay.
Decrease in mass storage, sir.
Okay, right. ஓகேமா. வேற?
Reheating of fluid.
சூப்பர்மா, அவ்வளவுதான். நான் லெட் மீ எக்ஸ்பிளைன் திஸ். இதை நான் தமிழ்ல சொல்றேன். என்ன, மியூட் பண்ணிக்கோ நந்தகுமார். இப்போ ஆக்சுவலா வந்து ஹீட் ஆகுது, ஃப்ளூயிட் வந்து ஃப்ளோ ஆகிறதுனால உள்ள என்ன ஆகுதுன்னு கேட்டிங்கன்னா ஹீட் ஆகுது. ஹீட் ஆச்சுன்னா என்ன நடக்கும்? உள்ள ஹீட் ஜெனரேட் ஆச்சுன்னா அங்க இருக்க ஃப்ளூயிட் சூடாகுமா? அப்போ ஸ்டீம் வந்து ரீஹீட் ஆகுது. இது ஒன் ஆஃப் த இஃபெக்ட். ஃப்ரிக்ஷன் இருக்கிறதுனால இது ஒரு எஃபெக்ட், ரீஹீட்டிங். அது ஒன். நெக்ஸ்ட், ஹீட் ஆச்சுன்னா டெம்பரேச்சர் இன்க்ரீஸ் ஆகுமா? டெம்பரேச்சர் இன்க்ரீஸ் ஆச்சுனாக்கா என்தால்பி என்ன ஆகும்? enthalpy also increases. So enthalpy drop இருக்கு இல்லையா, that is another factor. One is if there is heat, reheating of fluid will be there. Then enthalpy of the fluid increases. Then as he said, mass flow rate decreases. What will happen to the velocity? Ashwin?
Sir.
velocity என்ன ஆகும்?
Velocity decrease.
Velocity
decrease ஆகும்.
Why? How? எப்படின்னு சொல்ல முடியுமா?
கரெக்டாக தெரியல சார்.
ஜஸ்ட் அந்த மேத்தமெட்டிக்கல் ரிலேஷனை யூஸ் பண்ணி பாரு. V2 is equal to 44.72 into root of H1 minus H2. இப்போ H1 வந்து 2800 இருக்குன்னு வச்சுக்கோ, H2 வந்து 2500 இருக்குன்னு வச்சுக்கோ. அப்போ 800 மைனஸ் 2500 நமக்கு 300 கிடைக்கும் இல்லையா? அதுக்கு நம்ம ரூட் எடுத்தோம்னா சம் வேல்யூ இருக்கும். அதை மல்டிப்ளை பண்ணீங்கன்னா யூ வில் கெட் சம் வேல்யூ. பட் ஹீட் ஆச்சுன்னா என்தால்பி என்ன ஆகும்னு சொன்னா, என்தால்பி இன்க்ரீஸ் ஆகும்னு சொன்னாங்க. அப்போ 2800 என்ட்ரி என்தால்பியா இருக்கும். எக்ஸிட் என்தால்பி ஃப்ரிக்ஷன் இருக்கிறதுனால ஹீட் ஆச்சுனாக்கா 2500 என்ன ஆகும், 2600 ஆயிடும். அப்போ டிஃபரன்ஸ் என்ன ஆயிடுது, டிஃபரன்ஸ் குறைஞ்சிருது. டிஃபரன்ஸ் குறைஞ்சதுனாக்கா மொதல் கேஸ்ல 300 இருந்த டிஃபரன்ஸ் ரெண்டாவது கேஸ்ல ஹீட் இருக்கும் போது டிஃபரன்ஸ் 200 ஆயிடுது. என்தால்பியில இருக்கக்கூடிய டிஃபரன்ஸ் என்ன ஆயிடுது, 200 ஆயிடுது. 200 ஆயிட்டுனா அந்த V2 is equal to 44.72 into அந்த ரூட் ஆஃப் H1 minus H2 வேல்யூ என்ன ஆகும், கம்மியாகுமா?
ஆமாம் சார்.
கம்மியாச்சுனாக்கா வெலாசிட்டி என்ன ஆகும்,
வெலாசிட்டி கம்மியாகும்.
அவ்வளவுதான். தட்ஸ் த லாஜிக். ஓகே, வெலாசிட்டி கம்மியாகும்ன்றது கரெக்ட் ஆன்சர். பட் திஸ் இஸ் த எக்ஸ்பிளனேஷன் ஃபார் இட். ஓகே
ஓகே சார். ஓகே
ஓகே. தென் anyone else from B section? Surya? Efficiency of nozzle. Hello? Are you there? Voice ne பேசுறது கேக்குதா?
எஸ் சார்.
சார் கேக்குதா?
சூர்யா.
கேக்குது சார்.
Efficiency of nozzle, Surya.
H1 minus H3 divided by H1 minus H3s.
சூப்பர். எப்படி ஸ்டேட்மெண்டா சொல்றது? H1 minus H3ங்கிறது என்னது, H1 minus H3sன்றது என்னது?
H1 minus H3ங்கிறது enthalpy change during entry and exit சார்.
ஓகே.
H1 minus H3sங்கிறது entry enthalpy minus mean enthalpy change.
No, a good try. நியர் கிட்ட ஆன்சர் கிட்ட வந்துட்டேன். நான் சொல்றேன் அது என்னன்றதை சொல்றேன், சரியா? கேட்டுக்கோ. அப்ப H1 minus H3ங்கிறது என்னன்னா ஆக்சுவல் என்தால்பி டிராப், சரியா? H1 minus H3ங்கிறது ஆக்சுவல் என்தால்பி டிராப். H1 minus H3s அப்படிங்கிறது ஐசோட்ரோபிக் என்தால்பி டிராப். ஓகே
ஓகே சார்.
That's it. இப்போ efficiency eta n is equal to H1 minus H3 divided by H1 minus H3s. That is mathematical relation. But theory எழுதும் போது எப்படி எழுதுறது? It is the ratio between actual enthalpy drop and isentropic enthalpy drop. H1 minus H3ங்கிறது actual enthalpy drop, H1 minus H3sங்கிறது isentropic enthalpy drop. ஓகே
ஓகே சார்.
ஓகே. Then Vimal. Vimal.
ஹலோ.
Vimal கேக்குதா?
கேக்குது சார்.
கிரிட்டிக்கல் பிரஷர் ரேஷியோ Vimal ஃபார்முலா மட்டும் சொல்லு.
ஹலோ.
கிரிட்டிக்கல் பிரஷர் ரேஷியோ ஃபார்முலா மட்டும் கேக்குதா நான் பேசுறது?
ஹலோ சார்.
யா கேக்குது.
கேக்குது சார்.
Okay, I think he's having some problem with this microphone or data.
சார் அவன் அடிக்கிறான் சார்.
நடிக்கிறான், எனக்கு தெரியுது. அப்படி நம்ம இப்படி சொன்னோம்னா நாம அவனுக்கு டேட்டால ப்ராப்ளம் இருக்குன்னு சொல்லிடுவோம்ட்டு அவன் எக்ஸ்பெக்ட் பண்றான். That is the case, right? என்ன விமல், கரெக்ட்டா?
கரெக்ட்டா?
ஹலோ
ஹலோ சார். 2 by n plus 1 power of n by n minus 1.
Super Vimal, very good. Awesome. Okay. Okay boys, have a good weekend. Just go through your subject. Go through the subject also. I'll share the PDF in the Google Classroom or WhatsApp. Just go through it. If you have any doubt, means we will meet again on Monday. Okay, and you get your doubts cleared. Okay.
Thank you,
Thank
sir.
you.
Thank you, sir.
Okay.
Thank you, sir.
Bye.
Bye.
Thank you, sir. Thank you.
Bye, sir.
Okay.
Thank you, sir.
Bye, sir.